Okay, welcome to the third and final nutrition discussion for the full semester. Now, this is a replica of the previous two nutrition discussions. If you hadn't witnessed or watched those, this one is live streamed today as we are inhibiting student gatherings with the COVID increases. So coming to you today live. And again, my name is Andy Sykes. I'm the Associate Director of Campus Recreation. I cover nutrition and strength conditioning for Wichita State University. And today I will be discussing how the human body utilizes food to power life and movement. And this is a topic that goes into energy systems and macronutrients and activity, as they're all balancing within a diet to help maintain weight or gain weight or lose weight. And that's really what I wanted people to understand. And a lot of questions that come of how much should I eat, when should I eat, what should I eat. This is a generalized overview of how you get to those answers, and it is individual to everyone. And so hopefully today we'll start to understand that. And I'm about to share my screen to show you a PowerPoint presentation. And if you have questions, you can email me. And I think my email address is listed at the end of today, but it is andy.sykes@wichita.edu. I do have the captioning on, so hopefully it understands my accent and it can read everything I'm saying, but we'll see how that goes at the end. For now, I'm going to share my screen and we'll talk about our PowerPoint. Okay, so you should be able to see my PowerPoint here titled How the Human Body Utilizes Food to Power Life and Movement. So I like to start this conversation by asking who has a diet, and normally I don't get many hands up when I ask that question, and people don't think they have a diet or don't think they're following a diet. And that is a common misconception. Of course you have a diet because you eat food. Without eating food, you wouldn't cease to exist. So we know that we must have a diet. Whether that's a common diet as listed, one of the ones listed on the screen, or you have your own, is up to you. So what I want today is talk about how these diets work, what they are, and maybe how you can create your own that will be unique to you and actually help you achieve your goals. So let's start by just kind of overviewing the ones that we have listed here. If you're not sure what they are, we have intermittent fasting. That is when you feed yourself for either 4 or 8 hours in a day and then fast for the remaining 16 or 20 hours. So what that's doing, it doesn't influence the type of food and the amount of food, but it does influence the time. And when we're in a fasted state, we have hormones circulating in our body that basically are trying to find energy. So they release energy, they're catabolic in nature. And this allows you to burn energy. So what we end up finding is when you do an intermittent fasting diet, you tend to lose weight. Paleo diets are kind of our whole foods. They're going back to kind of what our ancestors may have been eating, really emphasizing lean proteins, vegetables, fruits, nuts, and seeds, while discouraging processed foods, sugars, dairies, and grains. Generally, we see maintenance of weight, but it depends on the volume that you're actually consuming. A lot of people can gain weight with a paleo diet. The keto diet is the absence of carbohydrates or the consumption below about 50 grams, where the body is producing its own sugars through ketosis. And that's what gives us its name. This is when we use fat and it's processed in the liver that produces ketones to actually produce energy and fuel our brain. We tend to see that people lose weight with the keto diet as we're having low amount of carbohydrate in our body. The topic that constantly comes up with carbohydrates, and I'll explain it as we talk about energy systems in the future slides, is that carbohydrates fuel the body when the heart rate is high or when we're intense. And if we're not getting the heart rate high and we're not intense, then we don't use those carbohydrates. And therefore, we don't really need to consume them. The brain requires about 130 grams a day. Past that is storage for use for higher intensities. If you were to be a fight or flight response, if you wanted to run, if you want to work out, you're going to use carbs, your heart rate's going to go up. But if you're not doing those types of activities, if your lifestyle is more sedentary, then you don't need as many carbs, and ketogenic diets tend to be pretty successful for people that are more sedentary and don't get their heart rate up. We got the vegan diet or even vegetarian diet. It's very similar. They're looking at plant-based foods. We generally see that a really good high consumption of vitamins and minerals when we're consuming these types of diets. However, there is some cause for concern. Are you getting enough protein? Now, it's absolutely can be successful. You can get enough. It just takes a little bit more attention to detail, a little bit more effort to achieve this. Low fat diets, as it suggests, not much fat in that diet. So this is kind of opposite of a ketogenic diet. With low fat, you're going to have lots of protein and lots of carbohydrate and minimize the fat content. For Atkins diets, it's split. It's a low carb diet, similar to what a ketogenic diet would see, but it's split into different phases, 4 phases. And we start to reintroduce carbohydrates slowly every day for about 2 weeks. And you just start to reintroduce different carbohydrates into that diet. So it's getting your body to use the fuels correctly and kind of resetting the system. The reverse diet, this is commonly used to gain weight, as it might suggest being a reverse. Okay, this is when we consume more and more calories and we try to hit a caloric ceiling. We try to eat as much as possible and then find a point when we start to gain weight. Once we find that, and that's known as our caloric ceiling, we can continue to either add or we can maintain at that point where we're highly fueled, but we're not gaining weight. Or we continue to add more calories and gain weight. What that does is increases the metabolism, makes your metabolism really quick. So then when you want to cut and want to lose weight, you don't have to have such a drastic cut in calories. Because your metabolism is so high, you can drop just a few hundred calories and see a change in the scale. So another method for maintaining, gaining, and losing weight with the reverse diet. Now, the vertical diet, the last one we got listed here, is really gained a lot of popularity recently, and a lot of the high athletes are consuming it. It's looking at red meat, white rice, electrolytes, and low digestive issue foods known as FODMAPs. And these are really kind of what the body needs and nothing else. You really don't get many phytochemicals from our fruits and vegetables in this diet. It's a really strict, and it's known as vertical because it's kind of just the things you need versus a broad horizontal diet, which has a large spectrum of different foods, lots of different minerals and vitamins, which would be opposite to the vertical. And then I've got there, create your own. So what could you eat to create your own diet? What do you need in that diet? And again, that depends uniquely on your lifestyle. And I'm going to try to explain what you need in today's lecture. So let's follow along as we move on and understand what goes into a diet and how we can improve it. So weight control, balancing our energy. Okay, we got a scale here of intake versus expenditure. Well, if we want to maintain weight, all we have to do is ensure that we intake the same amount of calories as we expend. Now, this was often a difficult task for us to figure out in previous years, but in 2020, that isn't so difficult. We can count our calories as our food goes in. Every food item that we consume has a food label. It's going to tell you the size of the portion. It's going to tell you the macronutrient content. It's going to tell you how many calories are in it. And then on the other side, we have smartwatches. We have different devices now that allow us to show heart rate, which correlates to energy expenditure and the calories that we expend per day. So we can really start tracking how much energy and calories is going into the body and how much is expending going out of the body. If those numbers are similar and they balance, we're going to maintain weight. If one is greater than the other, we're either going to see a weight change of increasing weight or decreasing weight. So understanding what you need. So why do we eat? Why do we drink? Why do we breathe? These are questions that I ask my class. And here's a clue here on our pictures. It is to produce energy. I like to compare this to a car. We often fuel up our car. We're all familiar with that. Why we need to go to the gas station is when our car is low on energy, we fill it up with gas. But if you had a horse, for say, as my image shows, and they are running low on energy, you can't go to the gas station and fuel those up. We need to feed them. And so that is what today's lecture is about. It's why do we eat? Why do we drink? Why do we breathe? All of those reasons are because we need to produce energy. And those are mechanisms to help us produce it. The amount and type of food that we need depends on our lifestyle. So it depends on that watch, that smartwatch, how many calories you're expending. Okay, if you want to maintain weight, you got to match the expenditure with the intake. If you want to gain or lose it, you got to have one that's dominant over the other. So the real source of food or energy, we start with photosynthesis, the energy from the sun. Now we can either eat those plants and gain the energy from those plants, or we can eat the animals that eat the plants and receive it that way. And I go into this a little bit more depth in my nutrition classes and my lectures, but the process of photosynthesis, which I think is really cool, and how it takes the carbon, oxygen, and hydrogens from the elements in nature and produces those into storage forms of carbohydrate. And so you can see glucose here is known as CnH2nOn. And we can simply put one glucose molecule, C6H12O6, actually produces oxygen when it's produced. So on the left side of this equation at the bottom there, you can see 6 carbon dioxide molecules and 6 water molecules with plus the energy of the sun going through the process of photosynthesis can produce a stored form of glucose, C6H12O6. But there's an additional 12 oxygens when this is stored. Well, this is why plants are said to release oxygen when they breathe, because when they store this energy that they take from the environment, they have a byproduct of O2. So they produce oxygen by storing energy, and we can then consume the oxygen, and actually we produce energy through the aerobic energy production or in our human body. But we can also consume the glucose stored in those plants, and we can go through glycolysis and break down that for energy. So let's look a little bit closer into that as we break down our food types into macronutrients. So our carbs, our fat, our protein. So here we've got some images of what they may look like. If you're not familiar with what a carbohydrate is, it's basically a plant-based food. We've got breads, potatoes, fruits there, bananas, some pastas, some rice. Okay, all foods that come from a plant source. And we use those, again, 130 grams a day for our brain function, plus anything to any time we get intense when we raise the heart rate. Our proteins, very commonly, our meats, our fishes, our chickens, our beefs, but also you've got some plant-based foods that have protein as well. Soy is well known as a complex, complete protein. But seeds and nuts also have different proteins, and there are many different plant sources that have proteins, but getting a complete protein source, meaning it has all of the essential amino acids, is vital for photosynthesis. So we need to get them all in our body. And there are 9 essential amino acids, 11 non-essential, meaning the 9 essential, we must consume those, and we can get those through really good complete sources, and protein, milk, and animal sources are the easiest way to do this. They're responsible for growing tissue. Protein is really well known for its ability for us to grow. Okay, but it's also important for us to change weight, fluctuate, and adapt. This helps us change weight, so we can actually lose weight by by consuming more protein, as well as gain weight by consuming more protein. It really depends on the total number of calories, and protein is just a facilitator of weight change. Protein is also important for producing peptide hormones, enzymes that actually break down our food. Our immune system is fueled by protein. We can have transport and fluid balance all happen because of protein in our diet. And then the last macronutrient, fat, often given a bad rap, but it is essential for our diet. We must consume them. And the example is shown, we've got some salmon there where you've got some fish oils that you'd get from that source, but other types of vegetable oils there, olive oils, olives, avocados, nuts, seeds, all good sources of fat. Fat gives us energy at rest. So right now, as you listen to this lecture, you're using fat as an energy resource. You're breathing at a low intensity, and energy is being derived from fat. Of course, past energy, it helps us stay insulated, stay warm, stay protected. It helps us receive nutrients. We have fat soluble nutrients that help that come in through fat in the body. It sure does taste good, so it helps us create a hunger, and actually has some satiety properties that keep us fuller for longer when we consume it. It's also responsible for producing some cholesterol-based hormones. So some of our sex hormones are fat derivatives, and gives us some cell structure. A lot of our phospholipids are the cell membranes of our cells. So they're made up of phospholipids. Roughly 98% of all the fats that we consume are triglycerides. So that's predominantly what I talk about in fat, but we also do have sterols, which produce cholesterol, and we also have phospholipids, as I mentioned, in cell membranes. So we want to try to consume around 20 to 35% of our diet being fat, but I'll get into those recommendations in a little bit, and I'll have them on the screen for us to talk about. So next up, the energy systems. Our body must produce a chemical known as ATP, adenosine triphosphate. Now we can do this, we can produce this adenosine triphosphate in 3 different ways, and it depends on the intensity that we need it. If we need it very, very quickly, very rapidly at a high intensity, we can use the phosphagen energy system. The example of this would be sprinting or jumping, potentially some immediate, a fight or flight response that can only be really used for about 15 seconds. I like to use the example, if I was to tell you to run as fast as you can and for as long as you can, you'll know that you can go all out for about 10 to 15 seconds before you realize that you're getting out of breath, you're getting out of energy, and you need to slow down. Well, that's because the most immediate energy resource, the phosphagen system, is running out of energy. It's able to only produce it at a high rate for about 15 seconds. We fuel this with creatine. Now, this is a common supplement, but it's also found in meat products, red meat, that helps us maintain this intensity. But if you were to keep running on my example, if you were to keep going, we know we must drop our intensity. We can't sprint all out forever. What happens is we switch to an anaerobic energy system known as glycolysis. The intensity of production of ATP is still high, but not as high. And we can do this for about a further 3 minutes. An example in life would be weight training or certain sports that you can have quite intensity bouts, but then need to lower the intensity and recover. In this energy system, we're using glucose to fuel the body and produce this ATP molecule. It's really good, it can do it quickly, but again, it's limited in its capacity at about 3 minutes. The example on sprinting was if you were to go and sprint, after about 10 seconds, we would slow down as we leave the phosphagen energy system and enter the anaerobic system. Well, at about 3 minutes later, you're going to hit known as a wall where you're jogging and you're not finding it very fun. Again, you're going to have to lower your intensity to maintain that movement. You can jog at a high intensity for about 3 minutes, after which point it becomes pretty uncomfortable. then you have to drop the intensity and continue moving. Okay, that's known as hitting that wall. Many of you have probably experienced that as you're running 3 minutes in-ish, you don't like it. Past that, you can kind of, oh, it's not too bad. You switch to the aerobic energy system, which is very low intensity of production of ATP. So that's why you have to slow down. But you can do this for unlimited amount of time. So this is where your marathons come in, that slower running speed, but for almost unlimited capacity of time. Okay, examples of just solo movements would be walking, and we're using fat as our resource where our heart rate is low. Again, I gave you earlier, I said that you are using this energy system right now. It's known as aerobic because we use oxygen. We go through a process known as the Krebs cycle, and we use oxygen as a hydrogen receptor, as hydrogens are produced as a byproduct in this system. When oxygen and hydrogen combine, we produce H2O, and that's easily shuttled and dealt with in the body. So kind of in another analogy, we could think of a fire where gasoline would be a phosphagen system, lighter fluid being the anaerobic system, and oil being the aerobic system. We could have a fire go for a long time with oil, but it wouldn't be very intense. We could add lighter fluid to really get that flame going, but gasoline would be the quickest flame and the most powerful flame. So kind of give you another way to think about it. But we don't live our life in that order. We actually live it in the opposite order. We live it aerobic to phosphagen. So we live in this aerobic state. We're breathing. We're at low intensities. We're generally sedentary. And occasionally we move around and we do things that require our heart rate to go up and reduce a little bit more energy. So we jump into that anaerobic system. And sometimes we go really intensely and we need to jump into that phosphagen system. But again, understand that we can't do so for very long because we run out of energy. We need this ATP molecule, and it's not produced at a high rate for very long. See here on the left, we have what's known as a crossover point graph, which shows the energy production at rest being mainly from fat. You can see that red line being close to 100%, while the intensity is at 0 at rest. And as the intensity increases and we go along here, we can see this red line coming down. So the reliance on fat is decreasing as intensity increases, and the reliance on carbohydrate increases as intensity increases. And so roughly we see that this crossover point where we become more reliant on carbohydrate versus fat is around 60% of our max. Now this is unique to everyone. It is a range, and it will be affected by your training and your lifestyle, even the diet that you consume. But you need to know that as your heart rate goes up, and exercise intensity is related to heart rate and energy consumption. So as we require more and more energy, we rely more and more on carbohydrate. If we don't rely on high intensity energy, we don't need a lot of energy because we don't do things, we're going to be using more fat-based foods. So understanding this and understanding what your life looks like in a 24-hour period gives us an idea of what we should be consuming, because we know what the body is being fueled by. Okay, what you need to fuel the body, because what it's going to be using. On the right side, you can see just heart rate estimated by 220 minus your age, the max heart rate, and I've done it for integers of 5 here. Max heart rate, 55 to 65%, which is roughly where we see this crossover point being. So you get an idea of what your age is. For me, I'm in this category. Between 105 and 124, I'm going to see my reliance switch to carbohydrate. So if I'm working out and I want to really get to that intensity, I know what heart rate I should be aiming for. And I know what fuel I'm going to be using, being more carbohydrate. I need to make sure that I'm carb loaded to be able to do this, to be able to do it successfully. Another way to look at this is we can look in the lab setting and we can actually take blood draws. And what we find is this is VO2 max on the left side of the scale. 85%, which is very intense, 65% kind of on that crossover point, 25% being more at that lower intensity. And then the amount of either amount of sugar, carbohydrate, or fat in the blood being used as energy. You can see at this low intensity, all of the majority of the energy is coming from free fatty acids, which is fat. It's our fat in our body. The breakdown of triglycerides to the free fatty acids. Very little comes from sugar, muscle glucose. Very little from muscle triglyceride. As intensity increases, and we do another blood draw, and I think this was probably done on a cycle erg, looking at intensity, you can see that we, of course, need more energy. More energy is being produced, released into the blood, so that we can actually utilize it and produce this ATP molecule. What you'll see here as the intensity increases, total energy obviously increases, but the reliance on sugar starts to increase. This is your muscle glucose and then your muscle glycogen. You see that this wasn't even present down here. Now we're getting more energy from these carbohydrate sources. Yes, still a little bit more from the fat. We're still using more fat at this higher intensity. And then as we go into a really high intensity, more reliance on muscle glucose, lots of reliance on muscle glycogen, which is the storage form of glucose. So it's still carbohydrates, and actually gets a little bit less for the fat. So more energy being produced total at a higher intensity and more coming from carbohydrates. So it kind of correlates and kind of supports what we thought about the crossover point in the previous slide. So how does that relate to you? Now we know this information. Now we know that a high heart rate requires carbohydrates and a low heart rate requires fat to fuel the systems and to produce the ATP so that we can actually stay alive and keep our cells energized. We can now understand and break down what your day looks like. And so here's an example, and you can do this for your own day. This is the time used on an average work day for employed persons aged 25 to 54 with children. So hopefully it covers a large population, and hopefully people watching are included in this. But again, do it to yourself. Track what you do in a day and figure out kind of what your day looks like. And this data comes from the Bureau of Labor Statistics in 2011. So it's about a decade out of date, but it's still great information. The average person between that age group with children is sleeping for 7.6 hours. They're at work for 8.8 hours. Leisure and sport, 2.5 hours. Household activities, 1.1, so on, so forth. You can kind of read it. Why is this important? Well, you want to be thinking about your heart rate at these times. While you're sleeping, a large percentage, so over about a third there, where's your heart rate? It's going to be low, right? You're not going to require much energy when you're sleeping. What about your work-related activities? Do you have a sedentary job where you sit at a desk, or are you more of manual labor where your heart rate might be a little higher? Understanding where that heart rate is key to understanding what the fuel system being used in the body is. Leisure and sport, we're probably going to see a higher heart rate there, where we're moving around and getting the sweat going. That's key because we know we're going to need carbohydrates to fuel the body during this period of time. And you kind of get the idea. You can start to understand every hour, every hour is 4% of your day. Break it down. What do you do in each hour? Where's your heart rate? Okay, then you can understand where the energy systems are and what we need to fuel and what we need to eat to fuel those systems. What are the recommendations? So based on that, you can start to figure out what you consume, but what are the recommendations existed by the government right now and our recommended daily allowance known as RDAs? Well, as I mentioned before, the brain requires 130 grams of carbohydrate a day. So that's actually the recommendation. You should eat 130 grams of carbs a day. So we don't need much more than what the brain requires. But it really depends on that heart rate. Are you getting your heart rate up a lot? Are you engaging in physical activity where you need a little bit more energy at that higher intensity? If that's the case, then you probably want to consume more carbohydrate. The recommendation is that 40 to 60% of your diet is carbohydrate. The range between 3 to 12 grams a day. 3 to 12 grams per kilogram per day. Sorry, there's a typo there. So again, it depends on what your lifestyle looks like. And the more active you are, the higher that number needs to be. The good thing about carbohydrates is the majority, our plant-based foods, they are high in vitamins and minerals. So having a large portion of your diet come from that really helps the nutrients in our diet be plentiful and helps lots of different functions within the body. The protein recommendation is 0.8 grams per kilogram. This is what everyone should be consuming, 0.8 grams per kilogram. Now, the recommendation can go up to 2 grams per kilogram, roughly a gram per pound. That's if you want weight change. If you want to lose weight, if you want to gain weight, you need to consume more protein. The recommendation is that it is 10 to 35% of your diet. And fat. There isn't actually a recommendation on the amount of fat, just a percentage of your diet being 20 to 30%. You do need to consume 2 essential fatty acids known as omega-3 and omega-6. These are commonly known fish oils, and the recommendations shown are 1.6 grams a day for males, 1.1 grams for females on omega-3, and omega-6 is 17 grams a day for males, 12 grams a day for females. It should be noted that these are unsaturated or polyunsaturated fats. We want to try to consume less than 7% of our diet through saturated fat, which basically means, is it solid or liquid at room temperature? That's an easy way to kind of identify a good versus a bad fat. When we're cooking beef, for example, it is high in saturated fat. When you cook beef, you'll see the oil and the fat drip out of the beef, and once it's cooled, it turns into a white, harder substance. That is a solid at room temperature fat. It's a saturated fat. It's not very good for you. It's more related to the coronary heart diseases and atherosclerosis, and different issues that come from high fat intake. So here's my slide. If you are a state employee health insurance employee and you need your HealthQuest point, the code word today is food is fuel, and that is the same code that I'm going to give my students. If you're watching this and you want your extra credit, email me food is fuel and I'll give you those points. If you are a state employee worker looking for the HealthQuest points, I will need your first and last name, your state employee number, identify whether you're an employee or a spouse, give me the code, and I will need your date of birth as well. So send me that information and I'll get your points uploaded. Water, probably one of the most important nutrients. We do need to drink water. It is vital in hydrolysis. So this is the breakdown of our food. Without water, we can't actually get the energy that is trapped inside of that food. Okay, it's very important. And around 60% of our body weight comes from water. The recommendation is 2.7 liters for a female and 3.7 liters for a male to be consuming a day. That's roughly 91 ounces for a female and 125 ounces for a male. However, this recommendation doesn't really account for how much food or activity that you're actually doing or consuming. I prefer the recommendation of 1 milliliter per kilocalorie consumed. So if you have a 3,000 calorie diet, consume 3 liters of water. If you have a 2,000 calorie diet, consume 2 liters of water. It's an easy way to make sure you're getting enough to help the breakdown of that food and keep you hydrated. You can see on the right side all the different functions that water has in addition to hydrolysis, but very important for our body. Okay, at the very beginning of these slides, we talked about the balance of energy in and energy out of the body. You saw it as a scale, both sides. Now we've talked about all the intake that the recommendations that exist for intake, but what about the recommendations for the expenditure to make sure we balance that scale? Well, the national goals are 150 minutes of activity a week, moderate exercise. So looking at that, it's about 30 minutes of cardio 3 times a week and resistance training twice a week. You can see any type really works for cardio. You just need to get that heart rate up. You want to burn some carbohydrates with a higher intensity heart rate. And resistance training is vital if you're trying to change weight. Okay, you've got to kind of create a metabolic drive in the body. When you resistance train, you create micro damage to the body and the muscles, and that requires repair and recovery. That then uses energy as you repair. And so you get this increased metabolic process as you synthesize proteins and repair the body. In general, I tell everyone, break a sweat every day. Get to a point where you're doing something that is hard for you every day. On the right side, this is something that I will tell my students. You can choose one or the other. You can choose to exercise, become stronger and fitter, spend 30 to 60 minutes a day in discomfort. As the recommendation shows, it is not long. That is only 2 to 4% of your day. Okay, we all know exercise can be difficult. It is uncomfortable. When we stretch, it should be discomfort. When we exercise, it should be to a point that is making us less comfortable than we were before. But post, we get that recovery, we get the adaptation, super compensation. We become stronger, we become fitter. You can choose to do that, or you can choose to not exercise and stay sedentary, have an energy surplus, probably gain weight, become weak, become injured. You'll spend 100% of your day uncomfortable, 24 hours. Would you choose to spend 2 to 4% of your day or 100% of your day uncomfortable? Because inevitably that is the choice that you're choosing. When it's put like that, I think it's an easier decision to make. We know we should be exercising. If that wasn't convincing enough, let's have a look at some of the research articles I pulled here. Some recent, some a little older. The evidence has been here all along. Fewer medical costs. Inactive adults pay almost $1,500 more in direct healthcare expenditures than active adults annually. That was in 2016, so not too long ago. So if we're saving $1,500 a year, hey, I think that's worth a gym membership. Employees that are more physically active are more productive. Want to get more done? Exercise. Improve work attendance and performance in 2015 for those that exercise. Reduced absenteeism. Okay, you're going to be more healthy. You're going to have less sick days, less trips to the doctor if you exercise. Improve morale and staff retention. A similar theme, even back in 1981. If you exercise, you will have an easier life. You will work better. You will be more productive, and you'll be happier. Now, the question on timing, I've talked about the intermittent fasting, but why does that matter? And it does have an impact, but only about 5% of really all of your diet is dependent on timing. It really doesn't have a huge impact, but it is definitely it's definitely there. So if we eat in the morning, it helps lower our cortisol levels. Cortisol is a catabolic hormone that is high when we're fasted. So when we go through an 8-hour sleep, we aren't eating anything, we're in a fasted state, and we're still alive, we're still trying to produce energy and maintain life. So the body releases cortisol to break down stored forms of energy and fuel the body. So if we want to lose weight, this is a good thing. If we're trying to gain weight, maintain weight, probably not the best. We want to fuel the body when we wake up. So breakfast is really important when we break that fast. Noon, when I look at midday, we want to have a emphasis on nutrient-dense foods, our fruits and vegetables. And really, again, depends on what you're planning to do that day. If you're having a workout, then make sure we're getting some foods that will fuel that workout. If it's going to get your heart rate up, we want some carbohydrates in there to fuel that system. What about in the evening? This is typically when most people have their largest meals. Well, that's fine if you're trying to gain weight, but a large meal in the evening is not good if you're trying to lose weight. Think about it. You're going to fuel the body. It's going to take in all this energy, and you're then going to go and sleep. You're not going to do much in the evening. So you're not using that energy. So what happens? It goes into storage, and hopefully you'll use it the next day. But if you don't, if you're sedentary, you're going to have this continuing storage and storage and storage without use of the energy. So we'll see weight gain. Snacks throughout the day. I always recommend a protein-based snack. It doesn't have to be a protein shake or a protein bar, it could be nuts and seeds. But having protein increases your thermic effect of food. It increases the metabolism. Protein is the hardest of the 3 macronutrients to break down. So the body works harder when you consume those foods. It increases the metabolism, actually burns more calories by consuming that food. And then exercise. We want to make sure that we have carbohydrate and protein in combination before and after exercise. Okay, carbohydrates before is vital if we're getting the heart rate up. Protein after to repair any damage that we would have caused in that workout. Carbohydrates after to replenish the storage so that if we were to need to get a higher heart rate again, we can. Again, this will depend on your goals. If you're trying to gain weight, we definitely want to replenish those stores. If we're trying to lose weight, probably don't need as many carbohydrates post as someone that's trying to maintain or gain. Okay, understanding our food labels. Every food item should have a food label, and you can see I've got an example on the left here. It covers the number of calories in that serving. It's important to know the serving size, as that can sometimes trick people up. It will show you the fat, the carbs, the protein, those macronutrients that are in the diet. And it's going to show you the 4 minerals or vitamins that we are deficient with in our nation or society. Those are vitamin D, calcium, iron, and potassium. So that helps us understand how much we're consuming so that we can get enough in our daily intake. Some of the things that I would say to look out for is some of the misconceiving claims on labels. So if you see something that says calorie free, it doesn't actually mean it has 0 calories, it just has to have less than 5. If something is fat free or sugar free, it just needs less than half a gram of that fat or sugar. If something is a good source, you say it's a good source of iron, it needs at least 10% of that nutrient's daily value. So what we recommend you take per day, it needs at least 10% of that. Similarly, high in needs more than 20% of the recommendation. High fiber needs more than 5 grams of fiber. Always good to look for our fiber. We're going to see those mainly on our plant-based foods. If something is lean, it needs less than 10 grams of fat, less than 4.5 grams of saturated fat, less than 95 grams of cholesterol. If something is light, we have a light version. Maybe we have a light version of ranch. It needs 1/3 of the calories or half the fat than a regular product needs. Low calories means less than 40 calories, low fat, less than 3 grams of fat. Low cholesterol, less than 20 milligrams of cholesterol and 2 grams or less of saturated fat. Low sodium, less than 140 milligrams of sodium. That's important for those looking to lose the water retention, as sodium always brings that with it. Have we tricks and tips when going to the shopping or grocery store? Don't shop hungry. Probably many of us have experienced this. When we shop hungry, we tend to buy more, and then we've got more at home and we'll eat more. If you are trying to lose weight or even maintain weight, just buy the foods that you're planning to eat. Make a list and try to get your 5 fruit and veg a day. And remember, portion size count. If you don't have a scale or you're not sure how big a portion is, on the right side, I show you some tips by using your hand to see different size scales. Half a cup being the lower part of your fist, an ounce can fit in your palm, a tablespoon, your thumb, a teaspoon, your index finger, 3 ounces of meat, say, would fit in your hand, and a cup would be your whole fist. So different ways that we can scale it. I often get the question, is a vegetarian diet superior? And I would say in general, yes, for the majority of the population. Now, there's a lot of discussion about carnivore diets being good, vegan diets being better. And it really depends on the person. And this is the key. It's unique to you. If you have any type of disease, metabolic disease, then you should be consuming high amounts of vegetarian, vegan diets. They are going to have the countermeasures needed to maintain your health. If you don't have those metabolic diseases and you're completely healthy, then wouldn't hurt you to be in a carnivore diet, but fruits and vegetables have so many different vitamins, minerals, and phytochemicals to maintain our health, to keep our different different data points in healthy alignment. The largest concern would be protein consumption, getting our complete protein sources that are more commonly found in animal-based foods. However, you're still able to do this with a vegetarian or vegan diet. It just takes a little bit more time, as I mentioned earlier. It takes a little bit more effort, making sure we get the full array. Commonly, foods in a vegetarian or vegan diet are paired. Rice and beans being a big example. For all the amino acids that aren't in rice are in beans, and the ones that aren't in beans are in rice. So being paired together, you can get a complete array of the essential amino acids that would be as good as a protein source. Now then you have to look into how many calories you're getting, how much fat you're getting based on those, because just you got the protein consumption down or content down. You then need to look at what are the other macronutrients scaled at. Supplementation, what things should we be looking at? Well, I always recommend a multivitamin, as most people's diets aren't very dense in nutrients. They don't have a large portion of fruits and veg in their diet. So a multivitamin wouldn't hurt you to make sure we're getting everything we need. Making sure that we do have what we are deficient in, the iron, vitamin D, calcium, potassium that are listed on our food labels. We need to consume those. Omega-3 and omega-6 that are essential. Often see that as a fish oil or a flaxseed oil that can be consumed as a supplement. And then protein, if you're not getting enough in your diet, having a protein supplement can help you when you're trying to change weight. Remember, that's not just gaining weight, as I know proteins powders are known for, also losing weight. You must consume enough protein to do that. I can't give this speech without a plug for our Campus Rec building. If you are a student, you know you have a free membership to our building. Also, any YMCA members have a free membership to the Heskett. And we have a plethora of different opportunities for you to get your heart rate up and burn some of those calories away. We have our performance suite, our diving and lap pool, locker rooms, table tennis courts, racquetball courts, squash courts. We have our circuit room downstairs, the 200-meter track upstairs, 2 hardboard fitness studios. We have full-size basketball, volleyball, and badminton courts, a rowing studio, an outdoor park course. We have 4 outdoor tennis courts. We have a futsal court and 2 half-court basketball courts outside. At a separate location, we have our Metroplex fields. We have the Bombardier Learjet facility. We have 26 fitness classes a week. We have intramural leagues going all semester long, as long as COVID isn't stopping those. And we also have the boathouse downtown where you can get on the water and on the river and exercise with a different method. So we have a lot of offering. And if you're not a member of the Heskett yet, it's only $40 a semester to join. It is the cheapest and by far the best offer in the city. So come take advantage of that. We have an app that we use that tells you about what's going on, the different fitness classes or lectures that are happening, activities that are going on, all over on our app. So you can download that for free. It is Fit Degree, the Fit Degree app, and you just log in with Wichita State. We haven't got any questions or time for questions today as this is a recording, but if you do have questions, email me at andy.sykes@wichita.edu. And I hope you have the great day. I hope you found this useful, and stay safe, continue to wear your mask, and use hand sanitizer. Stay safe, everyone. Goodbye.